right, we have made it to the end of chapter 2. Now we're going to be looking at some absolute value functions and how to solve, actually how to graph them more specifically using the idea of slope, as well as doing some equations and inequalities of those. So let's get started. Absolute value graphs. The graph of an absolute value function takes on the form where I have, right thickness here, f of x equals a times the absolute value of x minus h plus k, where h is the horizontal shift, k is the vertical shift, and a is the slope of a line. So kind of like the absolute value of the slope of the line. So I'm going to put that there for you. We'll talk about that in just a minute. Now, remember that if a is negative, like this guy right here, if a is negative, then the graph is going to be reflected over the x-axis. So we're doing a lot of stuff that we saw back in chapter 1 when we were doing those transformations of that. Now, remember that you have to take the opposite of what you're looking at to do the horizontal shift of that. Take the sign as is for your vertical shift up and down. So look at this first example. First example, I have opposite of that plus 1 that I see means that not going positive 1, I'm going negative 1 on the x-axis. So that means I'm going to the left by 1. This is your vertical shift. So we're going to take that same sign. That means we're going to go down by 2. And we have a 1/2 out front that's positive. So the shape of our graph is going to be kind of that upward V, but I'm going to adjust kind of the thickness of the vertical stretch or the vertical shrink of that graph, if you recall from section 1.5. So this vertex, or all the points, are going to move left 1 and down 2. So I'm going to think about that vertex. Remember, it kind of started here at the origin. And where would it go if it goes left 1 and down 2? That gives me this new point. Let me change colors here so we know. So the blue is going to be our graph, our overall graph. Now, from here, you could plot points. You could throw a 0 in here and figure out what you get. But the idea of this 1/2 out front is that the slope is 1/2. Now, in order to get that V shape, that means that one slope has to be positive, the other slope has to be negative. So that means I'm going to go up 1 for my rise, over 2 for my run. So for slope, we would go up 1, over 2 to get another point. If it was one complete line, I could continue to do that, but it's not. It's an absolute value function. So now let's go in the other direction. Let's go up 1 and to the left 2, up 1 and to the left 2, and that gives me my new graph for that absolute value. So we didn't have the idea of slope ahead of time. I didn't touch too much on those that had a number out front, but that does qualify kind of for the slopes of those two lines that we have. Now, an absolute value function is nothing but a piecewise function where this is part of a line, this is part of a line, but we kind of take off the bottom piece to make that V. Okay, let's look at the next example for this G function. Notice I have a negative 3 out front. Well, the negative should kind of caution you to where you know it has to go upside down in a reflection over the x-axis. This negative 2 here takes the opposite of what I'm looking at, so I'm going to go to the right by 2. And this is my vertical shift up or down. This one would be a positive 3, therefore it goes up by 3. Now, this 3 out front means that the slope of my line is going to be 3 over 1. Now, it's actually a positive 3 over 1 and a negative 3 over 1. So remember, that's going to help us with our rise over run, but I also have to account that it is going down. All right, so our original origin, remember, there's where my original graph is. So that means that I'm going to now move this origin to the right by 2 and up by 3. Right by 2 and up by 3 gives me this is kind of my new turnaround. Now, if it was positive, I would end up making it sure it goes like this, but now it's negative, so that means I'm going to have my V shape upside down. This slope, rise over run, so that means I'm going in the downward direction. We're going to go down 3 to the right 1. And get a new point. Down 3, right 1. Up or down, left or right. Down 3 to the left 1 will also give me that other point, and I could keep doing that down 3 and to the left 1, give me some ideal points on that absolute value. Again, it's all about patterns, making sure you understand each of those pieces in this generic form that we have in our definition. Now, can we go backwards? If I give you an absolute value function, can you tell me what the equation is? Well, notice here, since it's going upward, that means that, since it's in this direction, we know that that a value has to be positive, okay? Now, we also know that that a value is the slope of these lines, so I can also determine that. So from this vertex, I go up 1 and over 1, 2, 3. Up 1 over 1, 2, 3. So that means that the slope, or my a value, is going to have to be a 1/3 out front. The other piece that I need is my horizontal and vertical shift. So notice from the origin, where that original turnaround point is, I go to the right by 2 and up by 1. So our h is 2, and our vertical k shift is 1. So how can I put that all together in this generic form that I have for an absolute value? Well, it's going to look like this. F of x equals my a, it's positive. The slope of those lines were 1/3, 1 up 1 over 3, whichever direction. Okay, this one is positive, this one is negative, but the idea is just the number that I need. Ultimately, that a value is positive because we are pointing kind of in an upward V. We're not going downward. This h goes inside with my x, so we went to the right by 2. This is where I have to show the opposite, so that better be an x minus 2, not an x plus 2. And we take this vertical sign as is. At the end, I need a plus 1. Therefore, this is the function that I need for what is given to me there in that graph. Okay? All right, very good. So, just a couple hits on some of those graphing ones. The majority of this section, though, is talking about how to solve absolute value equations and inequalities. So, as a reminder, the absolute value of a number x is defined to be the distance from 0. Given an equation like this, where I say absolute value of x equals 2, let's say, there are two values that are actually going to work and satisfy that equation. So let's ask ourselves, if I have a number in absolute value, or from the distance from 0, what two numbers give me a distance from 0? Well, if I think about a number line, here's 0, I go 2 to the right, gives me 2, I go 2 to the left, that gives me negative 2. Therefore, those two values, x equals 2 and negative 2, would be solutions to this equation. Those would be the two answers that work. Because with an absolute value, other than 0, 0 doesn't work, but any other number would have two values that are the same distance from 0. One on the positive side, one on the negative side. So therefore, this is kind of what I do setting up an absolute value equation. I have something inside that, call it star, is equal to some number a. In order to solve an absolute value equation, you must set up two equations. I cannot stress that enough. I will not give you very much partial credit if you do not set up two equations. You have to set up two things. So one equation is going to look exactly like you have here, except for I take away the absolute value symbol. Okay, because why? What inside here had to equal this positive 2, or it had to equal the negative 2, right? So I'm basically saying, okay, x has to equal 2 here. So I'm going to rewrite that as is without the absolute value to get one equation. Or what's inside here, that star value, or what's inside here had to equal the opposite of that. So that means that what's inside there has to equal the opposite of a. Creating two separate equations. They will be solved alike, but they will give you two different answers because you're starting with one being a positive a and the other being a negative a. So let's talk about this first one. I want to solve the absolute value of x plus 2 equaling 6. So that means that whatever is inside here has to equal 6, and whatever is inside here has to equal the opposite of that for the whole absolute value to be 6. So here's my two equations. Again, you have to set them up. Let's rewrite this equation as is by just taking away the absolute value. So I just took away the absolute values there. So what's inside there can equal the positive version of that, or what's inside there, that x plus 2, can also equal negative 6, so that when I take the absolute value, I get a positive 6. So there's our two equations, and each one of those is going to be solved exactly the same to get our solution. So in order to get x by itself, I'm one step away by subtracting 2. So I get x equals 4, or, again, subtract 2 here, that's gone, and I get x equals negative 8. Therefore, giving me the two values that would make that statement true. There are only going to be two numbers here. The only time there would only be one number is if this value here was 0, but that's kind of boring because we're looking at the distance from 0 to 0, okay? All right, let's try this next one. This next one has absolute value of 2x minus 3 equals 11. Separating into two different equations. One is exactly as it stands except for I take away the absolute value, because what I'm saying is whatever's inside here can equal 11, or whatever's inside there could equal the negative of that version as negative 11, so that whenever I take the absolute value of that, I will end up with positive 11. So again, you have two separate equations. This one being one where it's equal to the positive, this one being the second one where it's equal to the negative version of your a value. We're going to solve this exactly the same. So let's start with this one. If I want to get x by itself, we're two steps away by first having to add 3 to both sides and get 2x equals 14. Then divide by the number next to the letter to get a 7 when I do that. Then I add 3 to both sides again. That goes away. This time I get 2x is equal to negative 8. And then when I divide both sides by the number next to the letter, I get negative 4. Therefore, 7 and negative 4 would be the solutions to my equation. So you're finding two answers that work always. Now, these are nice ones because I already have the absolute value by itself. So we can evolve into equations when we have to do a little bit of work to get our absolute value equation by itself. I like to have it by itself on the left side before you do the split. Now notice this 3 outside. I have many students who like to attempt by distributing that 3. That is not the case. We have to isolate this absolute value by itself first, okay? Now, if you don't like to be able to do this with this whole thing here, if I want to get this by itself, let me just exchange that. If I said 3w plus 7 equals 10, I take out that absolute value of 1 minus 3x and I just put in a w for that. Can you now see that in order to get that absolute value by itself, it's just like getting this letter by itself. So I would have to subtract 7 from both sides and then divide by 3. So let's do that. Now, if you need to keep it in terms of w, then sub back in. Go right ahead and do so. But let's see what happens when I do that. So to get this term by itself, I first need to subtract 7 from both sides. So that goes away, leaves me 3. Absolute value of 1 minus 3x is equal to 3. And then I need to get this absolute value by itself, so I'm going to divide. This is multiply here, so when I divide by 3 both sides, what I now get is absolute value of 1 minus 3x is equal to positive 1. And that will give us two answers. That's an absolute value equation that I have gotten the absolute value term by itself. And then I need to split it up first to get my two equations so I can get max credit there. And when I do that, I need to rewrite it as is without the absolute value. So what's inside here can equal positive 1, or what's inside here can equal the opposite of this version, which is negative 1. And now we have two equations we need to solve. So if I want to get x by itself, I need to get rid of this 1. Now notice it's a positive 1. So be careful when you're solving ones like this. That might be a little tricky for you. What I get left over is minus 3x on the left, 0 on the right. When I divide by negative 3 both sides, then I get x equals. Now, be careful. Students that make a mistake on this all the time. 0 divided by any number is 0. It's a valid number. The problem comes when the 0 is in the bottom, which is not what we have here. All right, so one answer is 0. I'm going to do the exact same thing to solve for the other one. So I'm going to subtract 1. That leaves me with minus 3x equals negative 2. And I'm going to again divide by the number next to the letter. Don't forget that negative. Don't forget to drop that down. And we get x equals, now look over here, can't reduce 2 and 3, but I can get rid of those double negatives to make a positive. So 2/3 would be one answer, and 0 is the other. Those are the two solutions for that absolute value equation. Okay, so this is important because the idea of this kind of falls in line also in the next part of section 2.5, which is dealing with solving absolute value inequalities. Now, we're going to first remind ourselves from algebra what happens when I solve an inequality and I'm dealing with negatives that I'm multiplying and dividing by. So we have to remember this very important rule. Turning our attention to inequalities, let's remind ourselves how to solve inequalities. Solving inequalities is just like solving an equation like we just did, but we have one very important rule. Now, we can add and subtract from both sides of our inequalities with no problem. That's not the issue. But when you multiply or divide by a negative number, you must flip the inequality sign. Okay, you must flip that inequality sign. Let me see if I can convince you of that. Originally, 1 is less than 2. Definitely. When I multiply by -2 both sides, what I do to one side, I have to do to the other. This gives me -2. That gives me -4. Now, how do these compare? Which number is bigger? Now, remember, you're in the negatives. This -2 is actually bigger than -4. So notice the flip of the inequality. So that's kind of a mini proof there, hopefully, to show you that that's when you have to change your inequality sign. So let's solve these two inequalities. Then we will use this idea in order to solve the absolute value inequalities. So if I'm going to get x by itself here, I need to add that 3 to both sides, and I get -2x. Bring your inequality straight down. I'm not changing it because I added to both sides. I did not multiply or divide. It only happens when you multiply or divide by a negative number. Now, -17 plus 3 gives me a -14. Now, if this was an equation, how would we get x by itself? We're going to divide by the number next to the letter, so therefore I need to divide by a -2, and you should have a flag in your mind waving at you or a bell ringing saying, ding, 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 you are dividing by a negative. Therefore, I have to flip that inequality sign. So I'm left with x, flip that sign, and reduce this number. -14 divided by -2 gives me a +7. Now, it says leave your answer in interval notation. I want all values that are greater than or equal to 7. Think about a number line, 7. Including 7, all values bigger than that. So for interval notation, I need a bracket because I have the equals. And I'm going off to infinity with a parenthesis because we can never reach infinity. So that would be your final answer for this inequality. All right, let's try one more of those. 2 steps away to get this x by itself. Notice the x is in this term right here, so I need to get rid of that +5 by subtracting 5 from both sides and be left with x over -3 greater than 11. And this time I have x and I'm dividing by -3. So to do the opposite of divide, I must multiply both sides by that number in the bottom, because now that cancels. -3 over 1. Those cross-cancel themselves out, leaving me with x, but I multiplied by a negative number. Therefore, that inequality has to flip. And we get 11 times -3, which is -33. So looking at a graph of that, all values less than -33 means I'm doing this. So I'm coming from -infinity and I'm stopping at -33. So interval notation, which we haven't seen in a little bit, gives me that for the solution of that equation. Okay? Or excuse me, for the inequality. It's not an equation. So we will now evolve into absolute value inequalities. So basically the equation that we just had, we now end up having to break that absolute value inequality into 2 separate positions. When I have a greater than situation where I have stars greater than A, you're going to have a graph that looks something like this, where I'm going to be at A and -A. Now notice I don't have equals, so I'm going to do an open circle. And you're going to have all these values that are bigger than A and all these values that are less than A. If I were to do a small, minute case. So that's what it's going to kind of look like. So notice I said, actually let's start at the top. Two things to remember with absolute value inequalities. You have to get your absolute value equation or expression by itself on the left side, and you must break that into two inequalities or a compound inequality. So for this one, notice I have great or than. That's the way I kind of stress saying that instead of greater than. Great or than means that I'm going to split this just very similar to what I had with the equation, where I have the conjunction or between them. Okay? Or the word. I think technically it's a disjunction because we have two separate inequalities here for our solution. So anyway, how do we set that up with that inequality? In a greater than situation, we're going to do exactly what we did with the equals. We're going to rewrite this as is without the absolute value. So that means that what inside there has to be bigger than A, which gives me this inequality. And I also know that what inside there has to be less than A to get my other inequality. So what's inside there doesn't change ever, but that means I have to flip the inequality and change the sign. So all we did before was change the sign. Now you got to flip the inequality and you have to change the sign to give me two separate inequalities that I can solve. Okay? So with the equals, I take care of when I'm equal to A and negative A. For the greater than, I'm taking care of all the values to the right of A and to the left of negative A. For the less than case, it is an and that combines the two. And what we are looking at now is the remaining pieces of our number line. We're looking at in between here, okay? So that means, that we are bounded in between negative A and A. And we saw some of those whenever we were working with some inequalities before in that interval notation. So I'm going to look at an absolute value that is less than A. Again, we can separate it into two with an and if we want, but when graphing it and finding the final solution, it's a little bit tricky. So this is where I want to incorporate what we refer to as a compound inequality. And a compound inequality basically is a statement that has three pieces to it. So here's what we're going to do. We're going to rewrite this as is without the absolute value, just like what we did with the greater than case. And just like what we did with the equals case. So I'm going to do what's inside there has to be less than A. Now, I can do and what's inside there, the star has to be greater. Let me write it out for you. Don't write this, but you can do it this way if you so choose. But I'm telling you, your solution is going to be hard for you to find. You have to find the overlap. So I don't like to do it that way. I choose to do it with a compound inequality because that helps me get it bounded between negative A and A. So I'm going to surround this one by its opposite. So there's where the negative A comes into play there. Okay? So rewrite it as is without the absolute value gives me this. Then I'm going to surround it by its opposite. Now, when you solve something like this, in order to get the x value by itself, you actually have three different places that you have to operate with. So whatever you do to this, you have to do to that, and you have to do to that. So let's look at this example. Solve each absolute value inequality. Leave your answers in interval notation. So doing a graph of this might help you with that interval notation if you're having trouble with that again. So here we have the absolute value of x plus 3 is less than or equal to 4. So we have a less than case. So there's our less than or equal to. This is our greater than case, okay, or greater than or equal to. So we need to split that up into this statement. So with an absolute value, you have to do two statements. One here, one here. The two statements of this combined one is this piece, and then this piece and that piece. Okay, those are the two pieces that I have combined together. So I'm going to rewrite this as is without the absolute value. And then I'm going to surround it by its opposite for the and situation, where it has to be less than 4 and it has to be greater than negative 4. That's how we would write it in that situation. So notice I have three different places, three different sections. I want to get x by itself, and I have this plus 3 hanging out. So I need to subtract 3 to get rid of it, which means I subtract 3 here, and I subtract 3 here. That goes away, leaves me x in the middle, which is good. Operate on the left gives me -7. Operate on the right gives me a +1. So graphically what this is telling me is that in between -7 and 1, I want all of those values. Now, by interval notation, when I'm bounding it between two numbers, that's the easiest. Now notice we have the equals, so we need a bracket going from -7 to +1. Close that bracket off, and that's my interval notation. Okay? All right, next one. It's another less than or, well, in this case we don't have an equals, but it's another less than case. So that means that I have to get that absolute value by itself, which I have, and I'm going to have less than 8. I'm going to split it into this compound inequality. So rewrite this as is without the absolute value, and I'm going to then, so it's less than 17, and it has to be greater than the opposite of -17. And there's our compound inequality. We want to get x by itself, so that means I need to get rid of that 5. So I'm going to do the opposite and subtract 5 in all 3 places. Then I get a -22 less than 3x, which is less than a 12. Not done yet because I have 3x, I need an x, so I'm going to divide by the number next to the letter, and in this case I need all 3 places. This goes away, leaves me an x in the middle, which is good. This can't be reduced, and I can't even do anything with that negative. I got to keep that with me, but 12 divided by 3 definitely reduces to be a 4. So I want all numbers, not including these endpoints, but between -22/3 and 4. By interval notation, we're going to use parentheses because there's no equals. We're going to go -22/3, 4, and that is our final answer. Okay. All right, very good. Now our last 2 examples in absolute value. This first one here gets us into this greater than case. So that means I'm going to rewrite it as is without the absolute value. Then I'm going to flip the inequality and change the sign to get the second equation, okay? So that's that idea where we're going to get a graph where I'm going to have 2 values here. I'm going to, with no equals, do an open circle at each, and we're going to end up going in this direction and in that direction. So let's see what those numbers have to be. We have to solve this first. So we're going to split into 2 inequalities. Rewrite this as is without the absolute value. Take that away, and everything else stays the same. X plus 5 has to be greater than 3, or what's inside there doesn't change. X plus 5 all over 2, that stays the same. I have to switch the inequality and switch the sign of my number. So I get less than -3 here. Now, just like any of these that we've done before, when we've had 2 equations or 2 inequalities, I have to solve it exactly the same. We'll get a different answer because I'm starting with different numbers. So x plus 5 all over 2. In order to get rid of that 2 and get in here to where this x is, let's get rid of that divide by 2. What's the opposite of divide by 2? Well, that's to times by 2 over 1, and I can cross cancel those out, so I would have to multiply this side by 2 also. So these cancel, leaving me with x plus 5 is greater than 3 times 2, which is 6. Final answer is going to come by getting rid of that 5 by subtracting 5, and I end up with x is greater than 1. So that means of all the numbers bigger than 1, that means this number has to be 1. I want everything bigger than that. Solve exactly the same. Get rid of the 2. I'm going to times by 2, times by 2. So I'm still left with that x plus 5. This time it has to be less than a -6. And when I subtract 5, be careful with those negatives. -6 minus 5 is -11. So x has to be less than -11. So I have everything less than that, everything bigger than that as my solution. Now let's remind ourselves of what interval notation looks like on a graph like this. So I'm going to come left to right. So I'm coming from -infinity to -11. So I'm going to do it under here. -infinity to -11. Then I'm going to union that starting at 1 to infinity. Now, no equals here, so I'm doing all parentheses with that -1 and 1. Obviously, with our infinities, it has to be a parenthesis at the ends. Okay? All right, and our last one here, looks like it might be a less than or equal to, but I like to throw ones in here like this. Again, don't distribute that -3. Isolate your absolute value first by itself. So I need to get rid of that -3 times that absolute value. Well, the opposite of times is divide. We're going to divide by that number that's in front of that absolute value to get rid of it. And that's going to cancel out, leaving me with that absolute value of x plus 7. Now, when I divide or multiply by a negative, what must we do that we talked about at the very top? We have to flip that inequality sign. You have to switch that. So since I'm divided by a -3 down here, that means I'm going to have to flip this from a less than or equal to a greater than or equal to. Do this division gives me a +9, and we're good to go, okay, to split things up. Because it is the greater than case, that means I have 2 of those inequalities split with an or. So I'm going to rewrite this first one as is without the absolute value. Or I'm going to rewrite what's inside there. Again, that stays the same. But what do I have to do? I have to flip this and negate that. So I get less than or equal to a -9. And this now is set up to get my 2 inequalities. Again, we're going to have something like this. Now this time it's equal to, so I'm going to do a solid circle here. But in each one of these greater than cases, I'm going to be looking at these 2 sections that I need to identify those numbers. So let's do that by solving for x. And we're going to subtract 7 from both sides and get x is greater than or equal to 2. Or subtract 7, that ends up with x has to be less than or equal to -16. So greater than or equal to 2, less than or equal to -16. These are kind of the inequality solutions, but what would it be in interval notation? I'm coming from -infinity and stopping at -16 to include that. So let's throw a bracket on there, parenthesis with the infinity, union, bracket at 2, go off to positive infinity, so positive to infinity, close that off with a parenthesis, and that would be your solution for this inequality, absolute value. Okay? All right, very good. So for this section, we're looking at reminding ourselves about some graphs of absolute values. That's a very small little piece. You need to make sure that on these absolute value equations and inequalities that you definitely break them up. It is a little bit tedious because you have multiple things to have to solve, but you have to break them up to be able to understand and master that concept that there's actually 2 different things that are going on in each one of those cases. So practice that, and we've made it to the end of chapter 2. So we will move on next to chapter 3, dealing with some power functions and polynomials. Until next time.